Hello everyone. Welcome to my channel BBTechHub. So right now I'm going to start the IPv4 addressing and the subnetting part of CCNA. And if you go for the syllabus of the Cisco Global Syllabus, you can see that 1.6 is nothing but describing about the IPv4 addresses and the subnetting. So in this video and the next one or two videos, I'm going to explain that IP address. But in the networking series, I gone through the details about the IP addresses. So who wants to learn in details about the IP address, they can follow those videos also. But in this one or two videos, I'm not going in details about the IP addresses because it's a time consuming process. But of course, I will summarize all the IPv4 part in these two consecutive videos. So let's start. So everyone, you see one thing, when this questions comes, that is the IP. Whenever we are designing a network, and in a network, when we need to identify the devices, we need this IP address. So that is, first of all, we have to design a network. So why we are designing a network? The question is that when there is a requirement for transferring the data from one device to another device, that moment we have to connect the devices, and when we connect the devices, we are nothing but designing a network. And the moment we are designing a network, that moment in a network, to identify the devices, we need the IP address. So that is the first and foremost thing, that we have to understand the network. So in this video, I'm going to cover about 30 topics, but I told you that I will summarize everything over here because all the details are given in the networking videos. Now the question, so when we are collection of devices, we are connecting for data communication purposes, we call it as a network. And in a network, what happens, every device is a node, yes? Whether it is router, switch, hub, modem, bridges, computers, all are the nodes. Those are the intermediary agent, and the node, that is the node we are using, that is IP address. And these devices are used for storing the data, run the data. Those are the host. Am I clear? It does not mean the node does not have the IP. I am saying that same thing. The node which is having the IP address and the capability of running the user's applications, store the data, those are called the host. So if you see the desktop, laptop, printer, smartphones, those comes under the host. So in a network, whenever we are identifying the node, we must have the IP address. So you can understand, we are designing the network, we want to access the data. But if we cannot connect the particular device, so our network is meaningless. So for accessing the devices in a network, we must have the IP address. Is it? Question is that the host, the device who is in the network playing the vital role, having two addresses. One is physical address and another is the logical address. So what is physical address? That is the physical identity. The moment we born, what happens? Our parents gives us a name, and we call by this name, we are recognized by this name, and wherever we go, we carry this name. This is our permanent address. This name gives us the identity, my own physical identity. But the moment I'm going to be the part of a team, I have to take the team membership. So the team membership is my logical, because whenever I change the team, my team membership is changing. Is it clear, everyone? So in the world, whenever a device is there and device want to take part in the networking, that device must have a physical address. That physical address in the networking world, we call it as a MAC address, media access control, which is a 48-bit. And when this device is going to be the member of a team, that is a network, the device has to take one membership number. That is nothing but my IP address. You think you are a student, you have a roll number in your school. You are a student in a coaching center. In the coaching center, you have also another roll number. You have an account in the HDFC bank. In the bank, you have been recognized by using your account number. You have an account in SBI. In the SBI, your identification is nothing but using your account number. But you, the person, is not changing. This is the physical identity. This is the physical address. But you, the person, when becoming the member of different groups, you are getting a group membership number. That is your IP address or logical address. That means, I think you can understand, our MAC never changes, but our IP may changes, because I'm changing the team, I am getting the new team membership number. But I am the person, my physical identity, it will never change. So in the networking world, this physical address, we call it as a MAC address. You can see, and it is of 48 bits, nothing to say. You people know. And this MAC address is divided into two parts. First 24 bit is OUI and second 24 bit is called as UAA. First 24 bit, this is the manufacturer's ID given by the IEEE. And the next 24 bit, who is the manufacturer, giving the serial number of the network interface card. And all total, it is nothing but my 24 plus 24 is 48 bits. So do you know how to check it? So let's see. Windows R, CMD. And here what I want to see, I want to see the MAC address of my computer. So nothing but that. Get MAC. Which command you are typing? Get MAC. Yes, what it is? Physical address. This is. You see 12 hexadecimal digits are there. Yes or no? I think you all know in the number system, if a number is the combination of the digit and alphabets, it must be a hexadecimal number. So here you see the 12 hexadecimal numbers are there. Every hexadecimal is of 4 bits. So 12 into 4 is 48 bits. Am I clear? You can use another command, that is ipconfig /all. Here also you can get the address. Yes, physical address. Understood? So this, whenever we want to check the physical address of a device, we can go for the computer, we can go for the get MAC command or ipconfig /all. Now it's good. The device has the physical address. Now the device is saying, I want to be the member of a team. So at that moment, we need the address that is called the IP address. And it is of course logical, I just told you, because it varies network to network. So whenever a device in a network, it must have an IP address for the identification. If the device does not have the IP address, you cannot access the device in a network. So here, IP address helps to locate any host in a network. Yes. And which command? Just I showed you. You can see I can, same command, nothing but ipconfig. Okay. If I run this command ipconfig, I get the three basic informations. What three basic information we get about my NIC card? I get the IP address, I get the subnet marks, and I get the default gateway. Clear? I want the total TCP/IP parameter setting. So just you add /all. And you can see what the informations you can get. Every informations you can get through this command. What are those address informations? Okay, 1 minute. See, DHCP enabled or not, the physical address, you can get the default gateway. Okay, here, come here. IP address, subnet marks, lease obtained, lease expired, default gateway, DHCP, every information you will get. So whenever we just want to know the IP address, just type ipconfig. But I want to know that the details, the total network settings, then I can go for the ipconfig /all. Now, this IP address has how many versions? This IP address has two versions, IPv4 and IPv6. When the IP Address was invented at that time. World could not predict what will be the scenario in future. So at that moment, the address space was 32-bit. And later on, when there is a crisis of IPv4, then the IPv6 came in picture along with the 128 bits. Fine. Now, here I am describing about the IPv4 because there is an IPv6 separate chapter, separate topic has been given in the global paper. So if I go for the 32 bits, it's a bit. Bit means 2 to the power. So 2 to the power 32, if I go, I can get that 4.3 billion IP addresses are available in the world, among which 3.7 billion IP addresses are used. And the IANA is the organization who is managing it under the operation of ICANN. Is it clear? Who is managing IANA? And this is operated by ICANN. Fine. So in the world, we are having 4.3, among which we are using 3.7 billion IP addresses. Now the concept is that the IP, we are saying the 32 bits, means here is the 32 zeros and ones combinations like that. Yes or no? Fine. So if I divide 32 by 4, that is 8 bit, you can see. And every 8 bit we call it as the octet. Am I clear? So you can see every IPv4 address consists of how many octets? 4 octets. Okay. Now, again, it is octet bits. So bit means binary. The base is 2. So if I go for 2 to the power, it is 256. So every octet's decimal value is 256. That means we can say 0 to 255, yes or no? Fine. So every octet start with the minimum value 0 and end with the maximum value 255. Am I clear? And this is the reason whenever we are writing any IP address, we have to write the address within 0 to 255. Why? So you understood? Because if I go for the every octet of 8 bit, 2 to the power 8 is 256, and that means 0 to 255. So whenever you are going to write an IP address, you have to write within 0 to 255. Is it? So if I write like that 10.2.3.4, you see 10 comes under 0 to 255, 2 comes under 0 to 255, 3 comes under 0 to 255, and 4 comes under 0 to 255. So now the question is that how many classes are there? Because this 4.3 billion IP is not a matter of joke to manage. To manage that, IPv4 addresses are divided into 5 classes based on the first octet value, my dear. Why? Because you see over here, why I have kept it blank to make you understand. So 0, octet start with 0, end with 255. Fine. So for class it is 0 to 127. Sorry, for class B it is 128 to 191. For class C this is 190 to 223. For class D it is 224 to 239. And for class it is 240 to 255. So what a nice game I played. IANA told I'm not going to touch any octet except the first octet. So IANA has made these 5 classes based on these 5 octets. Is it clear? Where this ABC is used for networking. D is used for multicast and E is used for research and development. R&D, research and development. Am I clear? So total 5 classes. Out of these 5 classes, ABC is used for the networking, D is used for multicast, and E is used for research and development. Fine. Now the question in this IPv4, we are talking about what type of addresses are there. So basically here we can see these are the 3 types of addresses. One is the unicast, multicast, broadcast. In the networking world, if one device is communicating with one device, so it is one-to-one, that is unicast. One device is communicating with several devices, that is one-to-many, that means multicast. Now, the one device is communicating with everyone in the network, whatever the devices are there. Every single device is communicating with every device at a time. That means one to all. And this is nothing but we call it as a broadcast communication. Is it clear? So we consider there are three categories of addresses in IPv4. One is my unicast, another is multicast, and third one is my broadcast. Fine. So remember one thing, IP address has a basic structure. Like in our family, in our name, if you go for your name is consist of two things. One is your name, another is the surname. Surname defines which family I belong, and my name identifies who am I from that family. So here is same thing. Every IP address, when you are assigning to a host, having two part. One is the network part, another is the host part. The host part is saying the device identity in the network, and the network part saying from which network, which family this host belongs. Clear? So every IP address consists of two parts. One is the network part, another is the host part. In the class A, out of 4 octet, only the first octet is reserved for the network and remaining 3 octet are reserved for the host. In case of class B, first 2 octets are reserved for the network and next 2 octets are reserved for the host. If you go for the class C, first 3 octet is reserved for network and last octet is reserved for my host. Same thing, I'll go for in two different ways. Once I will go for the octet format. Next, I will go for the bit format. So you see in the network octet, in the class A, 1 network octet, for class B, 2 network octet, for class C, 3 network octet. And in case of class A, the host octet are 3. In case of class B, host octet are 2. And the host octet of class C is 1. Now I'm just same thing going in a format of the bits. In the class A, 8-bit is network, 16-bit network in B, and 24 network bits in class C. In case of class A, 24 bits are in host, 16 bits are in host for class B, and in case of class C, 8 bits. Is it, everyone? So far whatever I have understood, that is the, sorry, whatever I have explained, that is the basic concept. So now I'm going for the next part. You can see what happens, what is NID, BID, and host ID. Okay, now you see what is NID, what is BID, and that what is host ID. So you can see NID means network ID, BID means broadcast ID, and the host ID. What is network ID? Every network has an IP address to identify for the network. Okay. So this NID is used to identify the network, which is of 32-bit only. Okay. And every host belong to a network must have the same NID. In this world, not a single host address is orphan. Every host address is having a network address and broadcast address. So in this networking field, whenever we see the IP address, we must know what is the network address of this host address and what is the broadcast address of that host address. Okay. So how to find it out? Suppose you are having an IP address like 192, sorry, I'm using this color. That is 192.168.1.1. This is an IP address, but we do not know what is the network address of this address. So how to find? You first find the class. This is the class C, and up to this 3 octet, it is network, and never touch it. You see, I have mentioned it. Do not change network octet. So you write as it is 192.168.1. And what is the host octet? If we put 0, this is the network address of that host address. Am I clear? What happens? That means whenever you get an IP address, and first if you identify the class and never change the network octet and put zeros to the all host octet, what is the resulting IP you are getting? That is nothing but the network address. Like if you see, I am having an IP address like 10.1.1.1. Which class? Class A. Only this first octet is network, remaining 3 is my host. So what will be the NID of this? 10.0.0.0. Am I clear? So whenever we get an IP address, this is the first task to identify the network. Okay. Now, next I'm going for the broadcast. What is broadcast? In a network, some situation comes when a single host send a common message to every host. At that moment, we need a common IP address, and that IP address is called nothing but broadcast ID or directed broadcast address. Fine. So now see what it will happen. Nothing, same as it is how you find NID. Only instead, in case of NID, in the host octet, we put 0. And in case of BID, in the host octet, we just put 255. Am I clear? So if I am having this IP, that is 192.168.1. If I put in the host octet 0, then it is NID, and if I put 255 in the host octet, then it become the BID. Am I clear, everyone? So how you can find NID and BID for a given IP? If you see IP address, just find the class. When the class you know, so you know how many bits are in network, keep as it is. Don't touch the network octet. In the host octet, if we put 0, then it is NID. In the host octet, if we put 255, then it is BID. Am I clear? So this, so we say in general, a network is a braid. In the braid, first piece is NID and the last piece is BID. And what the pieces we have? We have the middle pieces, that is host ID. So what is the host ID? The valid IP addresses we can assign to the host in a network is the host ID. Am I clear? And the way from where the host ID is starting, after NID, the first IP is the first valid host IP, and before BID, that is the last valid host ID. This is the range from where we can assign IP address to the host of a network. Clear? So that's why I have mentioned the valid IP addresses which can be assigned to the host of a network is called as host ID. Is it clear? And all IP address in between NID and BID are the host ID. Okay. Here is the question. Some situation comes, how to find the first valid host? Don't worry. Add 1 with the last octet of NID. Suppose 192.168.1.0 is the NID. If you add with the 1 with the last octet, then what is the IP you are getting? That is the first valid host. If in this network 192.168.1.255 is the BID, and if you just subtract 1 from the last octet of BID, the resulting IP is my last valid host. Am I clear? Everyone, practice it. Add 1 with the last octet of NID, you will get the first valid host. Subtract 1 from the last octet of BID, you will get the last valid host. Okay, fine. Again, I am saying if you want to go for the details, I have mentioned everything in the network series IP addresses. You can go for that. You will get every the clarity. Now, what is the IANA? IANA has reserved some bits from every classes. If you go for the class A, IANA has reserved 1 bit, that is nothing but the 0 from the first octet. In the class B, IANA has reserved 2 bits, that is 10. Class C, 3 bits, that is 110. If you go for the class D, IANA has reserved 4 bits, that is 1110. And in the class E also, it is reserved 4 bits, that is 4 ones. Am I clear? This is called the IANA reserve bits. Next, if I go for the IPv4 address that we should know, because in this IP out of 5 classes, A, B, C is used for networking. So now we will see in the class A, how many networks are there, in class B, how many networks, and in class C, how many networks are there. In class A, if I go for the total number of network, means 2 to the power number of network bits minus 1. In the class A, network bit is 8. That means 2 to the power 8 minus 1. That is 2 to the power 7. 128 networks are possible from class A. You can see the total is 128, valid is 126, because 0 networks cannot use and 127 also cannot use. 0 is reserved for the default routing and 127 is reserved for our loopback address. Fine. If I go for the class B, the same concept, if you want to find the number of networks, so 2 to the power number of network bits, but you have to minus over here 2 because IANA has reserved 2 bits for the class B. So you can get the 16,384 networks are possible in class B. Same thing if you go for the class C. In the class C also same 2 to the power number of network bits, but here you have to minus 3 because IANA has reserved 3 bits from class C. So you will get these many networks in class C. Am I clear? Now here is a question. A, B, C. I have find it out that networks. Now we'll see in every network how many hosts are possible. That means total hosts per network per class. Clear? In the class A, the total host bit is 24. So you can get this many total hosts. But if you say the valid, because I have to minus NID and BID, then you will get this number of hosts. In case of class B, host bits are 16. So 2 to the power 16 is this much, 65,536. I have to minus NID and BID to get the valid IP addresses. So you will get 65,534 host addresses are possible per network of class B. Now I am going for the class C. Here you can see the net host bit is 8. So 2 to the power 8 is 256. Total host 256. But I have to minus 2 NID and BID. So for every class C network, we will get 254 host addresses. Understood? So now the question is TCP/IP parameters. Whenever we are configuring the network settings for a computer, so which file of the operating system is helping us? That is TCP/IP properties. In this TCP/IP properties, there are some parameters are there. As an IT admin or as a network person, you should know every parameter while designing the network settings for your computer. Am I clear? If you want your computer will run nicely in the network, then as an admin or network person, you have to configure the every parameters very carefully. Is it? So whenever you learn the IP address, you should learn these 5 parameters also. So what are the 5 parameters comes under TCP/IP properties? The first is the host address, second is the subnet mask, third is my default gateway, next is my primary DNS server, and last one is my alternate DNS server. So for your kind of information, I'm telling you, whenever we are going to assign IP address to a computer, we have 2 options. One is the static, another is my dynamic. Do you want to see? I'm showing you. Come here to my virtual machines. This is my virtual computer. Here I'm showcasing you how we can assign IP address. Windows R. I'm going for ncpa.cpl. Fine. You can see this is my network adapter. Go to the properties. Here you can see IPv6 and IPv4. I'm go to the IPv4 properties and now see what if I click this radio button, that means I'm going to assign the static IP. And if I click this radio button, that means I'm going for the automatic IP. But right now I'm giving the computer as the static IP. That is, suppose I'm giving 11.1.1.1. Subnet mask automatic comes. Okay. Fine. I want to check the IP. Nothing. CMD. And here I am writing IP and fake. 1 minute. Let me little bit do the modifications over here. Okay. Fine. So what the IP address I have got from in this computer, that is 11.1.1.1. And this is nothing but static IP. Do you want to check? C / all. What happened? DHCP is enabled? No. That means if it is yes, means remember my computer is getting the automatic IP address from the DHCP server. Fine. So what are the ways I can assign IP to my device? I can assign the IP in 2 ways, static and dynamic. Who is assigning static? The admin. Manually. Clear? Who is assigning dynamic? Nothing but who? That is my DHCP server. How? Automatically. Okay. Fine. So that means whenever we are going to assign IP to a host, I can go for static or I can go for the dynamic. Static means fixed. What the IP the admin has assigned, it will remain same until again the admin is not going to change the IP. But dynamic, it is changeable because DHCP server never give the IP permanently. It gives the IP address in lease basis for during some time. Okay. Now here is the question: is there any problem of assigning static? Yes, there are some issues are there while we are assigning IP address statically. And what is the solution? We go for the DHCP server. We configure a server in our network and we assign IP address to the host dynamically by using the help of the DHCP server. Now see what the benefit. Assigning static IP is a time-consuming process in a large network, in enterprise network. If someone is going to assign the IP address manually, it is just next to impossible. Next, while assigning, we can go for some typing mistake. Maybe we can go for some IP conflict. IP conflict means more than one host having the same IP address. By mistake, we can do it. So two machines having the same IP, my dear, they never communicate because it's not possible more than one device can have the same IP in a same network. Okay. Next is the security issue. Static IP, fixed IP for a long time. A hacker can several times try with the same IP. That means my system is vulnerable. So that's why in a production network, we prefer that is dynamic IP. Who is giving? DHCP server. As an admin, you have to configure the DHCP server. Fine. So now we will see a little bit what is DHCP. What is DHCP? DHCP stands for Dynamic Host Configuration Protocol. I have mentioned it in the OSI reference model in the networking series. You can see DHCP is an application layer protocol and it uses port number 67 for server and 68 for client. And it is an UDP based service. And the main function of this protocol is to assign TCP IP settings to the other devices in a network automatically. What is the job role of DHCP? DHCP is a service and the job role of this service is to provide the TCP IP settings to the other devices in a network automatically. That means the moment other clients are getting the TCP IP settings from the DHCP server, they can run smoothly in the network. Is it clear? But for this, DHCP server follows a process that called as the DORA. DORA is nothing but discover, offer, request, and acknowledgement. Okay. So here, what happens? DORA process is not initiated by the server. It is initiated by the client. So whenever what happens, a client in a network, suppose a machine, I'm showing you. This machine, you check it. What happens? You see, just I kept like that. Now see the situation. Once we go for like that, obtain an IP address automatically, the system understand, TCP IP understand today, the IP address will not be assigned manually. So the client will start searching a DHCP server in the network. Am I clear? That means this process is initiated by the client. So DORA is the process which is initiated by the client to get an IP address from the DHCP server is called the DORA. That is discover, offer, request, and acknowledgement. Am I clear, everyone? So DORA process is always, remember, is initiated by the client, not by the server. Fine. Now, here we will see how to check the connectivity between two hosts. So whenever we are connecting the host in a network and assigning IP addresses, and what will happen? We can check the connectivity by using the command ping, packet internet gopher. I am writing over ping and the IP address of the other computer. I am having another host in this network and the IP address of that host is 11.1.2. Am I getting the reply? That means this system is connected with this system. This PC is connected with this PC. Am I clear, everyone? This is also another computer. So if I share a file in this computer, so from this computer, I can access the resources. Is it clear? So whenever we are assigning IP address in a network, so always please check the connectivity with that. If I want, my system must get the IP address from the DHCP server. Right now, what is the situation? So what happens? I'm keeping my machine in the NAT connection. Okay, in the VM, whenever we go for the NAT, what will happen? Our machine get 1 minute. I'll get it. Go to properties and I'm just make it opt-in automatically. See what happened. Here I'm writing over here, that is IP config. Okay. Now see, this is IP. Now see, my machine has got the IP address. Do you want to see DHCP is enabled or not? Okay. Now see what happens. Can you see? From where my machine is getting the IP address? My machine is getting the IP address from what? My machine is getting IP address from the DHCP server. Is it clear? Now I want to disconnect my client from the DHCP server. So what I will do? I will do ipconfig/release. Once we run this command, always remember my computer, my client is disconnected from the DHCP server. You see, I'm showing you. See, sorry, you see, have you got another IP 169.254? So remember, this address we call as the APIPA. The moment this is called APIPA. APIPA stands for automatic private IP addressing. If there is some reason my client get disconnected from the DHCP server, don't worry. The client will not be the IP-less. Is it clear? So the client itself gets an IP address from its base. From which network? That is 169.254.254. Is it clear? This is the IP address which is kept inside the host in operating system. The moment client senses that it is not getting IP address from the DHCP server, the client itself will take one IP address from this range, 169.254.0.0. And this IP address, we call it as a APIPA. Okay, now see, I want my client should get connected to get the IP address. So again, I will say renew. These two are very important command. You want to disconnect the client, then you type ipconfig/release. You want your client should get connected with the DHCP, you type the command ipconfig/renew. Now see, my IP has got. Do you want to see it is getting IP from DHCP or not? See, hello, have you seen my DHCP server is enabled? Fine. So everyone, you understood how to assign the IP address to the computer, how to check the connectivity, how to verify my system is getting static IP or getting the dynamic IP. I think you all understood up to this. Fine. So I'm keeping up to this in this video. In the next video, I will complete the remaining part of the IP address. That is what those are part coming. So I told you in the TCP IP properties, these are the vital things. In the next part, I will complete subnet marks, default gateway, primary DNS and alternate DNS. So hope so you understood. Again, I'm saying you want in details, follow the network videos where I have made lots of videos on IP addresses. So up to that, thank you much. We'll meet on the next video.